Hello everyone. Hope everyone can see my screen, right?
Yes.
Yeah,
Yes, I can see.
yeah. So we'll begin with today's topic and we'll try to cover exception handling today. So uh, j- uh, j- why do we require exception handling in Java? So see, whenever you write a program in and if the program executes normally and if there is no abnormal interrupt in the program, then what happens, the program successfully runs. But there might be certain cases when there is some interruption to the program, or there is some error in the program such that the regular flow of the program is disrupted. So in that case, Java has a mechanism to uh, prevent this abnormal flow of execution of the program, such that that particular exception is getting handled through some mechanism, and that mechanism is known as exception handling in Java. So there can be like several uh, types of situations. We'll go through it. What are the situations that can come when an exception in a Java program uh, can occur? So basically in this module, we'll talk about introduction to exceptions. What are the types of exceptions? That is like unchecked exceptions, checked exceptions. Then we'll try to see like what are the mechanisms Java provides to handle those situations. Suppose there is some interruption in the program or some abnormal flow such that the regular flow is not uh, working properly, or suppose the program got terminated forcefully due to some particular reason. So we'll try to see that how we can counter those things, how Java provides certain measures such that we can try to minimize those situations. So there are like different types of mechanisms like the try catch block, then there is like the finally clause, then we have the throws clause. We'll go through these one by one. Then there is like custom exception. So custom exception is generally like sometimes you would want to define your own user defined exception. So that is a way of using custom exception, and you will be using custom exception a lot when you create real time projects. And means Java has its own built-in uh, built-in exception handling as well, but sometimes you might need to write your own custom exception handling such that according to the requirements of your project you basically handle that situation. So those are basically known as custom exceptions or user defined exceptions. And then there is like exception chaining. So exception chaining and exception propagation are two things like which you will see a lot when you basically uh, create your Spring Boot projects. So what happens, like suppose at database layer there is some exception that has occurred, and that particular call is being made by some other module. So what happens, how that exception which is being thrown at the database layer is being caught at a different layer, and again if at that particular layer also there is some exception, then how it is being handled at some other layer. So that is basically called as like exception chaining or exception propagation. We'll see each one of these one by one. So let's go through it. So see, exception is an abnormal situation occurred in a code. If code is trying to so there are some examples of exceptions which might occur in a program. So we'll go through these examples. So you will get to know that what are the types of situations in which you might need to handle the exceptions. So see, if code is trying to get file on the disk, but file is missing, abnormal situation occurs. So what happens? Suppose you are trying to read through a file. You have kept one of the files in some your in one of your document folders or in your workspace. Means in Java there are mechanisms through which you can read through a file, but the file itself is like missing, or the path that you have provided to read the file is wrong. That means your code is trying to get the file on the disk, but the file is already not there, or the path that you have provided to read the file is wrong. So in that case basically you will get some issues, and that is like an abnormal situation. Some issues you will get at runtime. So that is basically that is basically an example of exception handling. Next, if code is trying to connect to the database server, but server is yet to be uploaded. What that means is, suppose there is some database server. So you can connect to the database server through some host, some port. So you will require some host, some port, and and s- and some protocols to connect to the database. Suppose you have some SQL developer or some other Oracle client that you want to connect to, and what you did was you provided some wrong host. That means that particular database server is not available. So when you try to connect to that database server, you will get some error, right? You will get some database server error or connection refused error. So in such a case you will have to basically handle the exception. So that is like another situation which is like a kind of exception in Java. Next, if code is solving an expression where if denominator is integer and becomes 0. So see what happens. Suppose you are dividing any number. So you have like the numerator part and you have the denominator part. And what happens at runtime, basically you provide the value of denominator as 0. So what happens? Division by 0 in mathematics is not possible, right? So in that case, you will get some kind of arithmetic exception. We'll see through these examples, but this is like an abnormal situation. Sometimes there will be certain situations which will occur at compile time. Your compiler will throw you the error, but sometimes there will be certain situations which you will only get to know at runtime. When you run the program, then you get to see those errors. So those are basically runtime errors. So see, if code is handling an array and exceeding array size. So we have seen how we can declare an array, right? So suppose you declared an array of size 10, and what you are trying to get is like you are trying to access the array index 15. You are trying to get the value at index 15 of array, but you know that the size of the array that you have declared is already 10. So it's just 10, it's 10, and you are trying to get something from the index 15. So that means that does not exist, right? So that will also give you an exception like array index out of bounds exception. I'll go through each of these types of exceptions when we see the demos, but these are some of the exception situations which might occur in your program. Then there might be certain situations like operating system related situations, like there is some memory issues, or there is some kind of like JVM issues in your system. So that can also occur. Sometimes there might be some hardware failure. So those are kind of like errors. So we'll see like there are certain things errors can occur, there is some situation like exceptions can occur. So errors are basically errors you cannot control through the Java exception handling mechanism. Means if there is some kind of like hardware failure or such situations, so those things you cannot control, but there are certain um, Java exception handling mechanism that can help to you to like combat a lot of the exception scenarios in your program such that your program does not abruptly terminate. So we'll see these situations. So these are some of the exception scenarios that might occur while writing a Java program. See this example. So this is a very simple example. So we have three variables like 10, a is equal to 10, b is equal to 0, and c. So what happens when you do c is equal to a by 0? So basically it is 10 upon 0. So when you do 10 upon 0, so that will be like division by 0 is not possible, right? So what will happen if you do not handle this exception? So you will only get this exception when you run this program. So this is a kind of runtime exception. So what happens when you run the program? Your program will forcefully terminate with an error code, exit code of 1. So when an program uh, terminates with a error code of 1, that means it is forcefully terminated, or the program did not complete its normal flow of execution. So this is one of the kinds of exception scenarios. Let me try to like show you some demos. Okay, we'll create one package. Let's say we name the package as exception.handling, and let's say we name the class as division. So what we will basically do, we'll create a main method, and let's say I'm just writing down the same program which we saw. Let's say I have like int c is equal to a upon b, and I'm trying to print out c. Let me try to run this program now. See, we got some exception, right? We got some exception. See, exception in thread main java.lang.arithmetic exception. So what it says is like division slash by 0, right? So it means division by 0. So basically division by 0 is not possible. That is why you got some kind of exception. Now let's just change this value. I'm just changing the value of b. When I try to run it now, this will execute fine, right? This is like successful execution of the program. But when I make it 0, means what happens? This is a value that you provide at runtime, and then the program starts showing these exception behaviors. So in Java, we have a mechanism that we can handle, and we'll try to like write some code such that what can happen. So when wherever you feel that there is a chance that exception can occur, see, whenever you write some code, you must think through it, that is there a possibility that there is a chance of some occurrence of any exception or errors. So see, in this scenario you can like think of like if the value of b is, see, as of now like I have hard coded some values for a is equal to 10 and b is equal to 0. Suppose uh, if you create some object and then you provide values at runtime for these values, for these variables, right? Then at that time you might not know like what the user is trying to, that user might tend to provide some invalid input as well, right? So suppose he provides some 0 or something. So in that case if you divide it, So you will get some exceptions. So you know that this piece of line of code can throw some exception. So we'll try to then wrap it through some of the exception handling blocks that we'll see. But this is an scenario where an exception can occur. So this line basically at line number 7 is throwing me exception. We'll see like how we can like counter this situation by the exception handling methods. See, the most important benefit of using checked exceptions in our programs is that the error handling code does not clutter up the regular code. This improves the program readability. Consider, for example, a method that has to read the contents of an entire file into memory, the pseudocode of which may be written as above. Okay. If we were to handle the various error conditions in this code and also inform the calling code of what went wrong, the code may look like this. Okay, we'll see some of the examples. See, this is one of the methods to read a file. To read through a file means in a file there is some text written, and what we are trying to do, we are trying to read the text from that particular file. So we'll see this is kind of like some pseudocode, means some of the steps how we can like perform this operation, how we can basically read through the file. So this is like some of the pseudocode. Pseudocode is like not exactly a program, but the steps which you can use to basically write a program. So this is kind of pseudocode. So what we are basically doing, we are just writing some kind of like we are having a variable like error code, and initially we are initializing it with a value of 0. So we'll try to like update this variable, means going through the program. So see what we are basically doing, we are opening the file. So for opening the file basically there will be some Java code written, but we are not concerned with the Java code. It is just some pseudocode or some steps how we can like perform the operation. So basically we are trying to open the file, and when the file is opened, we'll determine the file length. And if we have got the file length, then we'll allocate the required memory. And if the memory is allocated, we'll read the file into memory. And see, now what are the steps? If read failed, error code is -1. If read did not fail, then error code is -2 or some abnormal situation, or else error code is equal to -3. So you see this code, what happens? There are like a lot of if else block for handling the code. There are like lot of if else blocks which are like handling these exception scenarios. But there can be like multiple more scenarios, and you will have to like write a lot of like if else conditional blocks. So this code becomes very cluttered, and it does not look more readable. So this is not a good way of handling an exception. So we Java has like different methods through which we can basically handle this exception. Let's see those things. See, now the same method using the Java exception handling would be written like this, and not only the code with such a style would be easier to read and more elegant, but there is nothing distracting in the main flow itself. And also one thing, when you use proper methods, when you use proper mechanisms to handle the exception, then the debugging will also be very useful. So by in your real time projects, right, you will have a lot of scenarios where you will have to basically uh, use debugging as well. So you will use debugging to basically see if there is some issue with your program. Sometimes you might not get the expected out which you might be expecting. So in such scenarios you need to debug your code. So whenever you use exception handling mechanisms, debugging will also be very easier. Then another advantage of this kind of exception handling is the ability to propagate error reporting up the call stack of methods. So what we mean by this is basically, see, I told you one example of database of error being thrown at the database layer, right? So if that error is i- if you make a call to the database layer, then that particular module receives that kind of exception, and that particular module may also be called by some other module. So there are mechanisms where we can like basically still call the above modules. Means suppose you have like module 1, module 2 and module 3. Module 3 is basically your database layer, module 2 is basically your service layer, and module 1 is basically your controller layer. So at database layer there is some exception that occurred. So what would happen if you are not handling the exception properly? At database layer itself, the error will be thrown, the exception will be thrown, and your program will interrupt. And at the controller layer or at the service layer, the program will not even know like what exactly happened. But you need to like send some kind of information to your caller. Means suppose like the service layer or module 2 called module 3. So module 2 should also basically know why the error occurred, what was the scenario that the error occurred, and module 1 says suppose calls module 1. So module 1 should also be aware that why the error has occurred. So module 1 calls module 2 calls module 3. So at module 3 we got some error. So that information should be propagated until module 1 as well. So there is like mechanism for that, and that is basically known as exception propagation. So in addition, Java style exception handling separates the business logic and error handling code from each other. So when we'll develop Spring Boot project, right, we'll see how we can basically separate out the exception handling mechanism from your Java code. So there are like mechanisms which through which we can like write the exception handling module separately, and in your Java code just call those exception handling scenarios. So what that does is it does not mess up the code, it does not make mess up the code, and that improves the readability of the code. So that is like another advantage of using exception handling. So another advantage of Java exception handling is the ability to group and differentiate error types. And since all exceptions in Java are objects, it is natural to take advantage of the class hierarchy of the exception class. For example, you may create an array exception class from which you may further inherit into invalid exception and element type exception and use them as required. So we'll see through this as we go further with the demo exercises. So see, we had seen this example where we were handling the read file method through if and else blocks, right? Now we'll see how we can better use Java exception handling mechanisms to handle this situation. So see, that read file method is written again, and what we are basically trying to do, see, that particular code is written in a try block. You see this try block, right? Try keyword, and there is an opening bracket and there is a closing bracket just before the catch. So we were expecting some error from these 4 or 5 steps, like opening the file, determining the file length, allocating the required memory, reading the file into memory, and closing the file. So the user is expecting some kind of error can happen through this any of these steps. So when you have some kind of uh, when you have some kind of situation where you feel that there might be certain abnormal execution of flow through these steps, what you will basically do, you will try to keep those in a try block. Just use this syntax, means just try to uh, provide a try block and write your code within that. Now what happens? If you write a try block, if you write a try block, you definitely have to write some catch block. So this is catch block. So there are like different types of uh, exception handling scenarios. Now see, in catch block what we are basically seeing, file open failed. So when the file open failed, what we need to basically do, or suppose say if the step 1 open the file is successful, so so you won't get any catch at here, like file open failed. So suppose you found some error at determining the file length. Suppose at step 2 determining the file length, you got some error. So this execution of program will go out from this try block, and it will try to see if there is a corresponding catch block. So determining the file length throw me some error. So this catch block, it will first go into the catch block like file open failed. So do something here. So it will see that there was no issue with file opening. There was no issue with file opening. So this do something here will not be executed. Now it will further go down. It will see another catch block. It will see that size determination failed. So yes, we had some issue in determining the file length. So size determination failed. So do something here. So whatever you write in this catch block, that will basically be handling the determining the file length error. So it will then get executed, means whatever is written in catch size determination field, do something here. So this will basically execute, and there are like three more catch blocks below this. There are three more catch blocks below this. So this will not get executed because the exception is already been handled. The exception is already been handled by this second catch block. So did you understand this example? And everyone, let me know if you understood this example, because this is very necessary such that you further, when you see the demos, now you will, then it will become more clear. But did you understand this example? Anyone having issues while understanding this program?
But let's see it on the demo first, then it will be clear for us.
Okay, you did not. Okay, I'll explain more, one more time, but let's just
Okay.
understand. See, we have a read file method, which is basically trying to read through the contents of a file. So in a file, basically you have some text written. In a file, you have some text written and you are trying to read through the file. And these are the steps to read through the file. These are the steps to read through the file. And the user feels that there can be a scenario where you might encounter some error while reading through the file. So see, there are like 5 steps, right? Open the file, determine the file length, allocate the required memory, read the file into memory, close the file. There are 5 steps to read a file. Now what happens? You can encounter error in any of the steps, right? Suppose opening the file was successful. So you did not get any error or exception in this first step. Now let's say determining the file length, you got some error in step number 2. So whenever you, as soon as you got the error in step number 2, determining the file length, so these 3 steps, the steps 3, 4 and 5, like allocating the required memory, read the file into memory, and closing the file, this did not get executed. So what will happen, it will try to go in the catch block and try to see if you have written any exception handling scenarios such that that can handle the issue. So you got the error or exception from determining the file length. That is the second step. So we will try to see if there is a catch block written such that there is some kind of like match to handle this error. So file open failed. So file open was successful, right? First step was successful. So this will not get executed. This catch block, whatever is written inside this catch block, will not get executed because file opening was successful. So there was no error thrown from the file opening. Now let's go in the second catch block. So see, size determination failed. So yes, determining the file length throws through some error, right? So the second catch block is able to catch that error. So do something here. So that means that whatever is written in between in this catch block will be executed. So see, whatever the type of error is thrown, so that type of catch block you need to have in your code such that it basically handles that particular error. So that is how Java handles the exception handling. So let's say I'll try to write, and now we'll try to see how we can handle this exception. So we saw this error, right? Like we got some error exception, like exception in thread main java.lang arithmetic exception division by 0. Also focus on this process finished with exit code 1. So process finished with exit code 1. So remember this. Now what I'm trying to do, I am basically trying to create a try block. Just see this. What I basically did, I wrote a try and then a pair of curly braces, and what I'm trying to do, I'm trying to place this piece of code in this try block. Now see, we are getting some kind of error here, right? And the editor is giving me some suggestion that catch or finally expected. So if you are expecting some error in this particular code, so what you did, you placed a try block here. Try block. So try block throws the exception. And what happens? You see this catch or finally is expected, right? So what you will basically do, you will try to write a catch, and then in Java there are like lot of exception handling classes or objects. So we'll try to see like what can basically handle this. So we know that this is a kind of arithmetic exception. This is a kind of arithmetic exception in Java. So what we'll basically do, we'll we'll pass a reference of arithmetic exception, and there's a method in exception like print stack trace. Basically this will like print you some kind of message. Now let's say, okay, now let's say, and see what, why is this throwing an error? Okay, let's say we initialized it to -1. Okay, now what happens, let me try to one more thing. I have written another catch block, and we have like exception and e dot print stack trace. So I have written two catch blocks here. So let me try to run this program now. So see, when you first ran the program, right? Okay, let me try to again comment this out and try to run this. C is equal to A by B. See, the output at line number 19 was not printed, right? When you did not use this try catch block. So what happened at line number 7? The error was thrown. The error was thrown, right? And you did not get any output after that. Why? Because your program terminated here itself. So it did not further go and see what you have written below this. So when you have not handled the exception, so this is what will happen. Your program will abruptly terminate, and whatever you have written below that line, that will not be executed. But let's see when we basically use this try catch block. So when we try to run this try catch block, so let me try to run this now. See, what you're getting now is try is equal to C is equal to A by B and catch arithmetic exception. Catch arithmetic exception. So this threw some error, but see, there are some differences in the error. You are still able to get whatever was the initial value of C is equal to -1, right? And what happened, like this particular line number 12, right? This catch block basically caught the exception. This handled the exception. And you can also see process finished with exit code 0. In previous time you might have seen process finished with exit code 1. So what that meant was that was a forceful termination of the program, and this is like successful execution of the program. So you are basically getting the you are basically handling the error or the exception at this catch block. So see what happens. C is equal to A by B. This is some kind of like arithmetic exception. So it got handled here. So this is a type of arithmetic exception, and that is why it got handled here. And this is like exception class exception. So we'll go through like the exception hierarchy as well. So when you see the exception hierarchy, you will come to know that exception is the parent class of this arithmetic exception. Means arithmetic exception is a kind of child class of this exception class. So what happens in such a scenario if the type of error was not handled here? So it will go to its parent class to see if the exception can be caught, if it can be handled at the parent level. So, and one more thing, if you are trying to write down the multiple catch blocks, you can write down any number of catch blocks, but there is a catch, like you cannot write the parent exception before the child exception. See, what is basically the error that is being thrown here? Exception java dot lang dot arithmetic exception has already been caught, and you are getting some red underline right here. So what that means is that this is a child class of this exception class, and if you already have a parent class before this, so the control of the java program or the java compiler will never reach here. So java compiler is basically throwing you an error. So remember this thing. So I'll write down some documentation. Catch block handles the exception, and also if multiple catch blocks are there, then the catch blocks must be in the order of child class and then parent class exception. So did you understand this one? Like why we got error here? Why the Java compiler threw error? Is this clear or not? Arithmetic exception is a child class of exception class. So it is definite that whatever exception can be caught here, it will definitely be caught here, right? You're understanding this? So whatever errors can be caught by this will definitely be caught by the parent class. So that is why this block must come here. So see, this exception is like more generic. This basically covers more kind of like exception handling scenarios. An arithmetic exception is a type of exception. So this cannot come, arithmetic exception cannot come after this catch block. So that is why we'll basically put these blocks in this order. First the child exception class and then this parent exception. So once you run this program, you will see that the process finished with exit code 0. That means when you see this exit code 0, that means this is like successful completion of the program. Means we got some exception in the at line number 10, but we had tried to handle this and we were able to handle this. We were able to handle this. So see, there's one more way you can learn about any code more clearly. So when you click over it, right, when you click over it and try to like go click over this, then you will go into some kind of documentation and just see this documentation. This is like some kind of inbuilt documentation that Java has. This is like called Java doc. So you will get to know about, like, you can read about the documentation in any class, right? If you just hover over this control and then just press this. So see, you go to the documentation of this class. So this is like Java doc. So you can like read more about this. So see this documentation thrown when an exceptional arithmetic condition has occurred. For example, an integer divided by 0 throws an instance of this class. Arithmetic exception objects may be constructed by the virtual machine and if the separation were disabled and or the stack trace was not writable. And see what is basically written when this was like introduced. So currently we are like going through Java 1.8, right? So this was like introduced in Java 1.0 itself, and this is like this is the constructor of arithmetic exception. So you can like basically go through the documentation. Any class that you click on, you can go through the documentation. You hover over this exception and then see, when you just hover over this, you see this public class exception extends throwable. Extends throwable. So can anyone tell me like what this means when you see public class exception extends throwable? So which is the parent class and which is the child class? Can you tell me? Everyone there?
Yes, can you try the question, sir?
Yeah. Public class exception extends throwable. So in this statement, which is the child class and which is the parent class? Yeah, I think TJ wrote the answer. Throwable is a parent. Throwable is a parent and exception is the child class, right? We have already seen this syntax while we were studying inheritance, right? Whenever we write something, class A extends B. So B is the parent class, A is the child class. So this is exactly that, right? So you can click over this exception as well. So when you click over this exception, you will basically go in the documentation of this exception class. So see, every method, every class cannot be taught to you, right? So what you need to do, you need to like explore and go into the documentation of that class. So this is like the best way to like know more of the methods or more about the class. So if you come through any class or if you come through any methods and you think that I do not know the functionality of this method or of this class, then what you can do, you can hover over that command or control, which for command for like the people who are using Mac, control for the people using Windows, just press control and click on this. So you will basically go into the documentation of that class and you can like read about that. You can basically read about that. See, the class exception and its subclasses are a form of throwable that indicates conditions that a reasonable application might want to catch. The class exception and any subclasses that are not also subclasses of runtime exception are checked exception. Means we'll go through it like what are checked exceptions, what are like unchecked or runtime exceptions. We'll see those through. But this is like one way of like, if you are, if there's no one around you, so how will you basically get to know like what this does? So you can like click on this and read through the documentation as well. So this example was clear, right? So we had seen that we had three variables like a, b and c, and all initialized with some initial values, and we were trying to perform some division here. And what happened, we were trying to divide it by 0. So we were expecting some kind of like arithmetic exception. So whatever code you feel that might throw some error or exception, you will place in the try block, and then the you will have multiple catch blocks to handle those exception. So this was handled here itself, like catch block. This was an arithmetic exception thrown at this line number 10. So this catch block at line number 15 was able to handle this, and that is why we were able to see process finished with exit code 0, and that's why this program completed successfully. And the one which we had seen earlier, where we did not use the try and catch block, that was throwing us process finished with exit code 1. So that is like abnormal execution of program, and that gives you an that will like terminate your program at that line itself. So we saw that when we were not using try and catch block, it terminated the program here itself, and whatever was like written, the print statement at line number 23 did not get executed. But here we are able to print whatever is, even after like exception has occurred here, we are still able to handle it here, and below whatever statements are there, you are able to execute. So this is a method, this is a very simple example of exception handling. So we'll go through like more examples as and when we'll see. So see, this is like another example what they are trying to do here. They are also trying to like do c is equal to a by b. This is the same example. So here they have written multiple catch blocks. So see, catch arithmetic exception e, and then they are trying to print out the message, and then again catch array index out of bound exception. So we are trying to uh, print out something, and then catch exception. So whichever catch block basically handles this error will get that particular error, and whichever catch block is not, so suppose the error got handled at the first block itself, arithmetic exception, so the below catch blocks will not get executed. So it got handled as the first catch block, so there is no need of execution of the next catch blocks. So this is like one of the simple programs of handling exceptions. Are you able to understand us or not? Is it clear or not? If you have not understood, let me know.
Hi, Prita.
Yes,
Uh,
yes, sir.
yeah, yeah. This example, was of course arithmetic exceptions, which means try and catch block handling exception. Uh, but blockers,
Hello.
but you didn't hear me. Sorry.
Yeah, I got until that point. Like this is an arithmetic exception, and we have a catch block for arithmetic exception. After that, I think I did not get what you're saying.
Okay. But my question, if a try blocks exception successfully without exception, if it is working, so which means child and the parent even tries as a parent
So you mean to say
demonstration, but the catches
so
the child. So if it try block is working fine, but the catch is not working, is it can we exception or
see
no?
if your try block is working perfectly fine, means you did not get any error at any of the lines. So your catch block will not be executed at all. Got it, guess so what happens
Yes.
if your try block, if any of the lines that you have written in the catch block did not throw any exception, means everything was like working perfectly, so your catch block will not be executed at all. Only when the try block at any of the statements in the try block is basically sending you some kind of exception, only then your catch block will be executed. Means if all the statements in the try block worked fine, right? So none of the catch blocks will be basically executed. So catch block is for handling the exception, and you need to handle the exception only when an exception in the Java program has occurred. If there is no exception, if all the statements in the try block ran perfectly fine, then none of the catch blocks will be executed. Got it?
So which means this is for handling exception, yes?
Yes, this catch
Okay.
block is for handling the exception, and try block is for like means wherever you feel that this piece of code might throw an error, you place that piece of code in try block. Means that is for like writing the code, and you must use a lot of these try and catch blocks when you are like writing some real time projects, because these are like very, means there are like other mechanisms also for handling exceptions which we'll see further, but exception handling is one of the must things, such that there are like lot of corner case scenarios that you can think in a real time project. So if this validation fails, or if there is an error in this scenario, what the user needs to see. So that's why you basically have a lot of like exception handling scenarios. So, also one more thing, like you cannot write a catch block without a try block. So, if you have a catch block, if you have a try block, you must have a catch block, and a catch block cannot be written independently. So, yeah, TJ has a question like, how do we know division is an arithmetic exception in case I don't know? Okay, so in that case, right, suppose you don't know that this is like exactly an arithmetic exception. So, then what you will do, basically, you understand one thing, that this is an exception. Exception is the parent class of arithmetic exception. You should note this one. Even if you write this, right, I've removed that arithmetic exception block itself. I've like removed this thing, and now I'm running this one with the exception block, because this is like a generic thing. You will still get that error. You will still be able to catch that thing, like java.lang.arithmetic exception by division by 0, and you're still able to print the statement below that. So that is also possible, but over a period of time with more practice, right, you will exactly know like which your line of code will throw which type of error. Means as of now, if you write this catch exception, means after all the try blocks, just write this catch exception, right, it will be able to handle your program. Why? Because this exception is the parent class of all those exceptions like arithmetic exception or array index out of bound exception. This exception class is the parent class of all those exceptions. So this will be able to handle those things. But over a period of time, when you try to use more and more exception handling, you should exactly know like what is the specific exception handling thing, what exception handling class I should basically use to catch that particular exception. TJ, this will also work fine. This is also working fine, but I would prefer that I write a arithmetic exception here. I would prefer that I would write an arithmetic exception here because this is a kind of arithmetic exception. This you will come to know like when you use more and more arithmetic exception, means as and when you do a lot of hands on, right, suppose you are like opening a file, then there will be some kind of like file of- means there will be certain classes like which might throw some exception like file handling exceptions. So there are like exception handling classes to handle those as well. We'll see that. Means I'll show you a glimpse of the hierarchy of the exception handling class as well. Then you will get to know more and more. But even if you remove this, this parent class exception will be able to handle this. But you will get to know over a period of time like which exception block you should basically, which catch block you should basically use to handle that. So see, now we have this slide like types of exception, and this is like checked exception and unchecked exception. So checked exception and unchecked exception, what are these? So basically in Java, there are certain exceptions that will come at compile time and certain exceptions that will come at runtime. So see, in this program that we saw, before running this program, the compiler is not throwing you any error, right? You are not seeing any syntax errors or anything as such here. Are you seeing anything as such? You're not seeing any syntax errors, right? So if before running your program you are not seeing any exception, so that is not your checked exception. So checked exception is also called compile time exception. So compile time errors you basically get even before running your program. So see, compile time error means you get some syntax related errors, so those are basically compile time errors, and those are checked exceptions. And whatever exceptions that you get only after running the program, so that is like your runtime exception. Runtime exceptions are also called unchecked exceptions. So that is the difference, checked exceptions or compile time exceptions. These checked exceptions you can get to know even before running your eh, program, and unchecked exceptions are basically the exceptions that basically occur only after running your program. That is why it is also called runtime exceptions. So can you tell me like this particular exception that was thrown here at line number 10, is this like runtime exception or compile time exception? Anyone? Just try guess. Yes, this is a runtime exception because there was no issue before we ran the program. We only came to know about this after we ran the program. We get to see the error. So this is a runtime exception. This arithmetic exception is kind of a runtime exception. So we'll go further into the slides. So see, unchecked exceptions represent condition that reflect errors in your program logic. So your program is not written properly, and only when you run your program, that logic is basically throwing you some kind of error. So your logic errors are basically that cannot be identified by the Java compiler, right? So whatever logic you are writing, there is some flaw in that. So that cannot be identified by the Java compiler because that is not syntax related. So that is not a compile time error. So you will basically get to know about that only when you run the program. So that is a kind of unchecked exception. So see, for example, division by 0, these are errors that should be corrected in the program code and should not be handled at runtime. So this is a runtime exception. Division by 0 is a runtime exception. Unchecked exceptions are also called runtime exceptions. I have already told you this. And checked exceptions represent conditions that, although exceptional, can reasonably be expected to occur, and if they do not occur, must be dealt with in the same way. For example, file not found or connection refused because server is down. So file not found or connection refused. We'll see these examples more and more. We'll see the exception hierarchy of checked exception and unchecked exception. So what types of exceptions you can categorize in checked exceptions and what you can basically categorize in unchecked exceptions. So checked exceptions are basically that must be handled by the user. Unchecked exceptions also must be handled by the user, but unchecked exception is more about the flaw in your logic. So that logic you must write correctly. So see, this is the exception class hierarchy. This is the exception class hierarchy. So one thing we have already known that object class is the parent class of all. So object is the at the highest hierarchy of any Java class. All the classes, whatever you create or whatever inbuilt classes of Java are there, they all inherit from this object class. So you can say like this object class is the super parent, means there is no class like which is like above this object class. So this is at the highest hierarchy. And then we have something called throwable. So there is like another class which is like throwable, and this throwable class is basically containing two more child classes, and those child classes are basically exceptions and error. So throwable is a child class of object class, and exceptions and errors are basically the child classes of this throwable. So you see this hierarchy, right? Object is the parent class, means it's the super parent class. Then throwable is the child of this object class. Then exceptions and errors are the child classes of this throwable. And see, what are the types of error that can occur? See, virtual machine error or hardware runtime error, assertion error. So these are the kinds of errors basically that are like categorized as error. So you do not have a control about this error. Suppose your VM breaks down or there is an issue with your operating system. So that you cannot handle at the Java program level. But what you can handle the exceptions. You can handle the exceptions in your Java program. So whatever we will see in this entire exception handling, we will see how to basically handle the exceptions, not to handle the errors. So you have control over how you can handle the exceptions. So we'll see about this left child class, means whatever we have two child classes of throwable, right? Exceptions and errors. So we'll basically see how we can handle the exceptions. So see, checked exceptions and unchecked exceptions. So these are now child classes of exceptions, checked exceptions and unchecked exceptions. So checked are like compile time exceptions, unchecked are basically runtime exceptions. So we'll see through this. Like IO exception is input output exception is basically like a checked exception, or unchecked exception, null pointer exception. So suppose you created some variable and you are trying to basically get the value of that variable, but that variable is basically null. So if you are trying to get something about from a variable that is like null, you will get null pointer exception, right? So these are basically scenarios of exception. So always remember this diagram. So this is exception class hierarchy. Object class is at the super parent level, like that is at the highest hierarchy. Then there is like throwable class, and throwable has two child classes. One is error, one is exceptions. Error is something that we do not have the control, and so we will not see in this class. And we will deal with exceptions. Exceptions are now categorized into two. One is checked exceptions, another is unchecked exceptions. So checked are basically like compile time exceptions, and unchecked are runtime exceptions. Now see, further this checked exceptions and unchecked exceptions are categorized. Now see, types of exceptions are like built-in exceptions and user-defined exception. So these checked exceptions and unchecked exceptions, this Java has like provided like built-in exceptions. Means this is like already there in the library of Java. You just have to basically use this type of exceptions. And then there is some user-defined exception. Means those are basically your custom exceptions that you need to write. Some exceptions on your own that can basically handle some of the scenarios in your project. So those are basically user defined exceptions that we'll see at the end of the class, but we'll go through this built-in exceptions first. So checked exceptions and unchecked exceptions. So let's see what are the scenarios in which you can see checked exceptions. See, class not found exception, interactive exception. Suppose you are trying to use a class which is basically not found itself. So you will basically get class not found exception. So this is kind of a compile time exception. Then there is some file not found exception, IO exception, instantiation exception, interrupted exception. So interrupted exception you will basically get when you try to use like threads. We'll see when we get through the topic of threads. Generally you will get a lot of these errors in using threads. That is like another topic. When we use that threads, I will show you like how basically you will get this interrupted exception. Then this IO exception. IO exception generally is like something related to input output related exceptions. And these are like exceptions you will get while reading the contents of a file, writing contents in a file. Basically, file related operations and those kind of operations you will get this input output exception. Then there is like instantiation exception. Instantiation means creating an object. To instantiate means to create an object. So when you are trying to create an object, you are getting some kind of error. So that is basically instantiation exception. That's a checked exception. Now there is like another exception like SQL exception. You started getting some error in your SQL handling code. So that is SQL is basically like writing queries, and you started getting some errors while writing those SQL exceptions that you need to handle at compile time. Then there is like file not found exception. You are basically trying to like access any file which is not there on the server, or which is not at the, or you are like providing the wrong path. So that is like file not found exception. So these are like some kinds of checked exception or like compile time exception. Now we'll see what are like unchecked exception. So arithmetic exception, this we had already seen, right? This is a runtime exception. Now we have like another exception like class cast exception. So we can like cast a class to other class. Suppose you have a parent class and you have a child class, right? So basically child class is a type of parent class, right? So there is a relationship. when you say animal and when you say categorize the animal, then you can say there are like two types of animals, domestic animals and wild animals, right? So you can say that domestic animals and wild animals, these are basically the child classes of animals, and you can further categorize that domestic animals into dog, cats and all, and wild animals into tigers, lions and all those things. So when you say dog, you know that dog is an animal, right? So dog is a type of animal itself, so that is that kind of relationship. So similarly in class cast exception, you can cast a class into other, means you can like typecast a class to other type of class. We have seen like how we were basically typecasting a data type into other, right? So similarly that is applicable in class cast as exception as well. So whenever we are casting one class into other and there is some type of exception through, then that is like class cast exception. Then there is like another type of exception, that is like null pointer exception. So if you are trying to get through some object that has like null value, if you are trying to get any attribute from that object which is like already null, then that will basically throw null pointer exception. Means suppose you have a class student. Listen to this example. You have a class student and it has like two attributes, id and name. And what basically you have done, you have assigned the value of null to student object. Now see, student object is basically null, so your id and name do not have any value. So what you are trying to do, from that object, student object, you are basically trying to get id and get name. Suppose you are trying to get it through some getters. We had seen some getters and setters yesterday last class, right? So you are trying to get the value of id and name from the student object, but student object was null. If you try to get any uh, attribute from an object and that object is already null, then you will get null pointer exception. So that is another scenario. Then there is like array index out of bounds exception. So this also I have already told you, that suppose you have an array of size declared 10 and you are trying to like access any index which is like beyond 10. Suppose you are trying to access array index 15 from that particular array, you will get array index out of bounds exception. Then there are like other exceptions like array store exceptions, illegal thread state exception. So illegal thread state exception, this you will basically get when we deal with threads handling. So we'll see this. Okay, let's see this try and catch clauses. Oh, 1 second. Now see this slide. See, this is like try and catch clauses. So we are trying to write the try and catch blocks. So in the first picture you can see that there are like multiple catch blocks written, and the same type of exception has been like mentioned in both the catch blocks. So this is not allowed in Java. Whenever there are like multiple catch blocks, they should have different types of exceptions. Here you can see that invalid index e and invalid index f. So the type of exception that we are like writing in both the catch blocks is same. So this is not allowed in Java. In either you should change one of them exception types. So this will never be allowed. Now see the right hand side of example. There is one try block and then there is like two catch blocks, and the first catch block is IO exception and the second class is file not found exception. So when you write multiple catch blocks, right, so super type of exception class should not be at the last. Sorry, super type of exception class should always be at the last. That means file not found exception is a child class of IO exception. So child class exception blocks must be placed first and then the parent class exceptions must be placed. So means IO exception is a parent of this file not found exception, and that is why if you write in this manner, if you mention the parent class exception first and child class exception after, you will get an error. So we had seen this thing, right, when we were handling this. When we had written this arithmetic exception below this exception, we got an error, right? Why? Because exception class is the parent of arithmetic exception. So that is why we were getting error. So similarly in this example as well, this file not found exception is a child class of IO exception, and that is why IO exception must be written below file not found exception. Understood this? Means the child class exception blocks must be written first and then followed by the parent class exception. If there's anything you want to ask about this, you can ask, or otherwise we'll proceed with the next slide. Okay. Now there is another thing, like there's a concept of finally block as well in Java. So what happens? The finally block is a set of code which receives execution irrespective of whether an exception is thrown or not. If there is a piece of code, cleanup code like releasing resources which needs to be executed irrespective of whether exception is thrown or not, that is in try as well in catch blocks, then this redundancy can be reduced by adding this code set at 1 in finally block. The finally block guarantees its execution once even if try or catch block has a return statement. Its execution is guaranteed even when exception is occurred, but it does not find suitable catch block. But if finally block also has a return statement, observe, okay, the reason is remembered when the finally clause exists by falling out of the bottom, but if the finally clause exits by executing a control flow statement such as a return or by throwing an exception, then this reason supersedes the original reason and the original reason is forgotten. Okay. Okay, let's read through this slide also and then I will show you another demo. Since the finally clause has its own return statement, the original return value is forgotten and the new return value is used. Okay. If a try clause is existing but catch is missing, then finally clause is mandatory. If a try or catch block is terminating execution by invoking system.exit, it terminates JVM's execution and thus execution control fails in reaching the finally block. Okay, we'll see this demo now. Why we basically use a finally block. So let's say I have written this try block. And I have not written any of these catch blocks. So I am getting some kind of syntax error, right? And you see what the editor is suggesting you: catch or finally expected. Catch or finally expected. So after writing try block, right, if you write this finally then your program will not throw you an error. Let's say you are printing something like in finally block. In finally block, and then you are running this. So you are basically able to see in finally block. So this will always be executed. This will this piece of code will always be executed, and we basically use this finally block. There are like different situations like releasing some memory, or like closing database connections, or closing some file. So suppose you have opened some connection to the database and you want to close that connection. So finally block is the right place to close those kind of like resource things. So you can close down the database connections here, you can close down the file here. So it is basically used for releasing the resources. But you can also put the finally block in situations where you want to feel that if your catch blocks is unable to handle any exception, right, then your finally block should execute. Okay, I will make some twist to this program. Let's say I've written this finally block. See, in this program we know that our arithmetic exception catch block was able to handle this error, this exception at line number 10, right? So do you feel that this particular statement will be executed in finally block? Anyone feels that this will be executed or this will not be executed? See, even if this catch block was executed, or this catch block was executed, or these catch blocks were not executed at all, this finally block will definitely execute. This finally block will definitely execute. So when I again run this, see, we are getting both the things, right? In finally block, this is getting executed and this is also getting printed, and we were able to handle the exception at this catch block itself. So this catch block was executed. Why? Because this is an arithmetic exception that was thrown, and this was handled at this catch block. But even after that, this finally block will definitely get executed. So I'll write down some documentation here. Finally block gets executed irrespective of whether the uh, catch block was able to handle the exception or not. So this is about the finally block. This will definitely be executed even if this catch block or this catch block was not executed. Now let's do one thing. Let me try to comment this catch exception block, and also let me try to comment out this one. And what I'm trying to do, I'm trying to write another catch block, and I'm writing index out of bound exception e index error. This way also you can like get some message, e dot get message. In this, right, when you have this exception, uh, when you pass the exception class reference here and you pass e or any parameter, basically we'll do this thing, e dot print stack trace and e dot get message to get the type of messages. So let's try to run this program. See, we are getting in finally block. So what happened? This was not handled at the arithmetic exception as well, but this finally block still got executed. This finally block still got executed. None of the catch blocks were executed, but still this finally block was executed. So remember one thing, finally block will definitely get executed irrespective of whether the catch block is able to handle the exception or not. Even if you do not have the catch block, if you do not have the catch block at all in your program, this finally block will definitely get executed. And generally this is for releasing the resources and closing the database connections, closing the servers, closing the file that has been opened. It is used for that purpose, this finally block. So let me again uncomment this. Okay. And also one thing, let's say there were some more points here. Okay, let me try to write some. Okay, we'll create some other program. I will create another program, exception demo. I'll create one main method and I'll create one method to perform the sum of two numbers. Let's say I have some initialized a local variable sum with a value of 0, and I have the try block where I am basically trying to do sum is equal to a plus b. Then I have a catch block, arithmetic exception. Then I have some finally block, and what I'm basically doing, since I have a return type of integer, I should return something. I should return this sum, which is basically holding the sum of two members. Whenever we have this return type, right, we must return a value from the method. Since we are returning an integer and sum is an integer value, we must definitely return this sum. Let's print out something in the finally block. In finally block, let me go ahead and try to create a object of this class. Let me try to print out the sum of I've called this method sum, which is basically returning me the sum of two variables. See, this method is basically taking two variables, integer a and integer b, and it's basically trying to calculate the sum, and then it's trying to return that sum. Now let's say what we are doing. Let's say we are returning returning 0 here itself. Okay, I've created the object of the class and I'm trying to call this sum method, and I'm passing both these parameters. This method expects two parameters, right? So I'm passing two parameters. So now let me try to run this program. See, we had a return statement here. We had a return statement here in try block. Even then, this finally block was executed. This finally block was executed, right? See, what does your return statement do? When you place some return statement, right? When you place some return statement, I have placed a return statement at line number 9. So the program generally returns, means stops, it does not process this particular thing. Whatever statements you have written below this, it will not process this and it will return this value. See the output. The output is 0 itself, right? The output is 0. But the output expected was 5 plus 10 was 15. If I comment this out, if I comment this statement return 0, I'll get an output of 15. See now. See, I'm getting an output of 15, right? But what happens now? Now, if I uncomment that return statement, so I have a sum of 15 in this sum variable, but this return 0 is returning me a 0. As soon as this return statement is encountered, this method terminates, means this method will return this particular value itself, 0. But still this finally block will get executed. This is the speciality of this finally block. See, you are able to see this value, right, in finally block. So this still gets executed. Now let me try to comment this out. I have commented this return statement. Now what I do, I'll basically return 0, return minus 1 from this finally block. Now I will start getting error. Now I'll start getting error. Why? Because I have returned something from the finally block itself. When I return something from the finally block itself, then what happens? In this block, this piece of code will never be reached. So this will throw me an error. Like this is unreachable statement. So this will throw me an error. Unreachable statement, compile error. So this will basically throw me an error. And finally return minus 1. So this is also unreachable statement. So basically you should not use this return in this finally statement. So I'll uncomment this one. So this is again infinitely block, and let's try to run this one. This is like infinitely block will always be executed, and I'm getting a sum of 15. Even if I like place this return in a try or catch block, this finally will still be executed. But for now, I am commenting this out. Did you understand this? Do you have any questions on this? Okay. Okay. Here they are like demonstrating some examples of finally block. So see, in try block, they are like throwing some arithmetic exception. I'll show you how we basically use this syntax as well, throw in new arithmetic exception. Even if like we are able to throw new arithmetic exception, right? So still this finally block will get executed. So we have seen that even if the exception was getting handled from the catch block, the finally block was still getting executed. So that is the speciality of this finally block. So we had seen other demo. See, in this class, basically what they are doing, they are trying to perform the some file input output operations. So these are like some file input stream operations. Like if we can like read through the contents of the file, we are trying to read through the contents of the file. So we'll get to know about this input stream and output stream. So input stream is basically a class where you'll basically read through a file. An output stream is a class that in Java basically helps you to write contents in a file. Input stream helps you to read contents from a file. Output stream helps you to write contents in a file. So basically we are trying to read through the contents of a file. So see at line number, sorry, we do not have a line number here. So input stream in equal to null, and what we basically did, we tried to create a object of this file input stream, and then we are trying to read through the file. In dot read not equal to -1, that means until we still have some kind of text left in the file, we should be able to read. So we are trying to read through the contents of the file, and we have some kind of catch block. Suppose we are trying to read through a file and that file itself is not found. So we get some kind of exception, and that exception is called file not found exception. So if this file was not found, so we would get some error, and we would we would be able to catch that exception at this file not found exception in this catch block. But this finally block will still be executed. This finally block will still be executed. And see, we are doing in dot close, right? So this is generally will perform while we have any resource opening things. So we are performing an input output operation. So this is something related to file. So this is opening some kind of like stream and closing some kind of stream. So this will perform in a finally block. So finally block is mainly used for closing database connections, closing the streams, closing the files. So this is mainly the usage of finally block, and it gets definitely called, means even if the exception was caught or handled in the catch block, your finally block will definitely be called. So is there any question that you have regarding the try, catch, or finally block? You understood the try, catch, and finally block?
Can you go to for as a intelligent demonstration?
Okay, you want me to go to IntelliJ? Okay.
Yeah, if you in a commented return 0, that is we can get output 15. So
If I
it's
uncomment
yeah,
this line, right?
when we uncomment,
Yes.
it give 15. 15 is as expected, so there isn't any exception issue, handler exception. Yes.
No, no. See, when I uncomment this one, right? when I uncomment this, we will not get 15 as output, right? We will get output as 0, right?
Zero, yeah. At
Why
this time, this is
why
for
we
handler
got
exception. Yeah,
why we got
yeah, I
0
got
was
that.
why we got 0 was this is a return statement. So whenever your program encounters any return statement, it will basically exit from that kind of method. It will basically exit from this method, and it will not print this sum. So generally this piece of at line number 19, the return statement that you had should be able to return you sum, but you already returned this value from here itself. So this return sum at line number 19 will not be executed. So you did not get the value 15, even though your sum variable had the value of 15, but you just returned a 0 from here. So this was never executed, but your finally block will still be executed. This is the speciality of finally block.
Yeah, so my question,
Okay.
if you, yeah, if we uncomment, that is we get zero. So this is for my understood exception issue, because there is no check it from cache statement. But when we commented, we got 15. So it is, there is no exception. Yes.
No, when you write a return 0, right, that is not an exception. The program is not giving you means any error, means that is some kind of like flaw in your logic, means you are performing your logic also perfectly fine and you are returning as well fine. So generally you should not return 0 from here. I was just trying to show that even if you write a return 0 here, your finally block gets executed. But this is not an exception scenario. This is not an exception scenario. You yourself, the user uh, himself, wrote this return 0. Means there is no flaw in your logic as well. It's just that you tend to return a 0 from this point itself. There is no exception scenario in this case. Got it?
Okay.
Yeah. One more thing I would like to let you know, that there is something called as system.exit. System.exit. Let's say I provide a system.exit here, and then I'm trying to run this. I'm trying to run this. So what happens now? See, when I did a return, let me try to uncomment this. When I tried to do a return 0, I did not get my expected output of 15, but still this finally block was executed. You remember this? This finally block was executed, right? I was getting in finally block and I was getting a value of 0. Means this finally block was still executed. But let's say I comment this return 0 and I uncomment this system.exit, and then I try to run. So at this time I'm not getting any output. At this time I'm not getting any output. So what this means, this is forceful termination of a program. Forceful termination of a Java program. So whenever you see some kind of statement like system.exit and you provide a status code of 1, so that means that this is a forceful termination of the program. And whenever you do a system.exit of 1, right, so this will be a forceful termination of your program, and at this point of time your program will abruptly terminate, and even your finally block will not be executed at this point of time. So this will not be executed as well. So this is clear to you, right? So whenever you have this forceful termination of the program with system.exit, nothing will get executed in the program below. This is clear now, Gasa?
Yes, I'm clear. But this forceful termination, when we use the below one return, it will be
Yeah,
execute or
when you use this return 0, right? No, if you uncomment this, if you uncomment both of this, right? See, whenever system.exit is encountered, this program will be terminated forcefully. Means nothing will be executed, not even your finally block will be executed. No return statement below this will also be executed. This is like system.exit 1. Whenever you do this, this is done. Means generally in your Java program, whenever you write production ready code, you don't use this system.exit 1 in your program. This is a bad practice. You do not
oh,
you do not forcefully terminate your program. But I'm just saying for this example that whenever the program sees this system.exit, it will just exit and it will not see any of the lines below this. Okay, so we have seen this slide. Okay, TJ has a question. How finally block useful to clean up the code? So see, TJ, whenever we have opened a database connection, means your Java file is basically trying to connect to the database. So you have opened a connection. So that connection is basically using some resource. And after, like, suppose you have connected to the database, and after connecting to the database, your database has some tables and that table contains some data. So you are writing some SQL query to fetch some of the data. Suppose there is one employee table in that particular uh, database, and you are trying to read the name and ID and salary of the employee. So you have written a SQL query and you are able to get those particular values in your Java program through that SQL query. So I'll show you how basically we can write SQL queries when we basically go through the Spring Boot program. But suppose you have fetched the some of the data from that database into your Java program. Now you have got the output, and now what you want to do, you do not want to keep your connection open because your database has performed your operation and now you want to like close the connection. So you will, in the finally block, the connection object that you have created for opening the database, you will do that connection dot close in the finally block such that you do not have a open connection to the database now. So this is like one example of closing the resource. Now, let's say there is another example where we are using some file handling operation to read the contents of a file. So in Java, we basically have input stream class to read the contents of a file. So we are trying to create an instance of input stream, and we are trying to pass the path of the file which we are trying to read the contents from. And then once we are done reading the contents of the file, then we would like to close that stream. Means file input stream, the instance that we created, we will try to close in that finally block so that we do not have this uh, 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 this stream still opened. So once you close these things, right, so resources are released. If you do not close these resources, like if you do not close the connections, if you do not close the streams, what will happen, a lot of the memory will be occupied in your Java heap. And in your Java heap, if a lot of the memory is occupied, sometimes your program or your application will crash. This you might see in some applications, in some real-time examples. when you write some production ready code, and if your if your application is not properly built, if the streams and these connections are not properly closed, sometime you will see in your error logs that the application crashed due to Java heap memory issue. So that is why we need to close these resources whenever we use finally block. So we'll basically close all the connections, all the streams that we open in the finally block. Okay, so you're saying we can use finally block anywhere in the class. See, your finally block will definitely be executed, but you should generally use it in proper manner, such that suppose you are opening a file, so that piece of code should be in your try block, and suppose you have performed some operations in the try block, and suppose you are expecting some kind of error as well, so you will try to have your catch block. You will try to have your catch block where the error can be caught, and in the finally block below that, basically you will try to close that particular file related stream, so that you will perform in the finally block. So finally block has a particular usage. Generally we will try to use finally block for mostly closing the resources and all. I was trying to like explain the finally block that it is still reachable, means this finally block is executed irrespective of like try and catch block. That is why I was like showing you those demos earlier, like I printed some logger statements that in finally block and all. But generally we would not be simply writing finally block. Finally block has a use case, and the use case is basically to close down the resources that we have opened in the Java program. So we'll try to use the finally block for that. Is it clear, TJ? Okay, so we'll see this throws clause now. So there is another way of handling exception. So there is this throws clause, and this clause is for method to declare what type of or types of exceptions a method code are capable of propagating. So this clause is mandatory for a method if programmer is not willing to handle exception at the method level and wants to propagate exception to upper layer for handling. So I told you, right? So in exception handling, generally we can propagate the error. I told you that example of module 1 calling module 2 and module 2 calling module 3, where module 3 was your database layer. So at database layer, basically we were getting some error, and that error, if we don't want to handle it at the same layer, we can throw that error to the upper layer, and upper layer can basically try to handle that error. So suppose say module 2 also does not want to handle that error, so we can propagate that error to module 1, so that error has to be now handled at module 1. So this is one of the examples of like propagating the error. And when you use this throws block, when you use basically this throws block, you can try to skip the catch block as well. There are examples where I'll show you how you can basically try to skip your catch block as well, and using throws itself you can try to handle your exception. And throws keyword, right? Throws keyword is like used at method level. So you can use this throws keyword at the method level, or when you write at the method, there itself you can like mention the type of exception that you are expecting. See, The clause is mandatory for method if programmer is not willing to handle exception at the method level and wants to propagate exception to upper layer for handling. Exceptions are thrown using the throw statement, which takes an object at its parameter. The thrown object must be a subclass of the throwable class. And exception can also be generated by calling a method that itself throws an exception. Okay, an exception can also be generated by calling a method that itself throws an exception. So there are like multiple keywords now. There is one thing like throws, and then there is something called throw. I will show you what is the difference in both of them in the demo. A method that throws an exception must declare what it throws by using the throws clause. A method can throw different type of exceptions, the list of which is given in the throws clause separated by commas. Okay, you can throw an exception of a class that is a subclass of the class declared in the throws clause. Because a clause can be used polymorphically anywhere, its superclass is expected. Okay, see this exception now. Now we are trying to create a throws demo, and what basically this does, we are trying to divide a number, and we have two variables. Like this method dividing numbers is basically taking two parameters, one is float and both the parameters of type float, and these parameters are I and j. And see, we are expecting an kind of like arithmetic exception. So what we are basically doing, we are basically trying to use throws keyword. Throws arithmetic exception. You see this at the method declaration only, right? Static float dividing numbers, then the two parameters, followed by throws arithmetic exception. So we are using this keyword throws at the method level itself, and in the try block we are writing some logic that if j is equal to 0, then we throw new arithmetic exception. So see, in this example, like we have skipped this catch block, right? We have skipped the catch block. We can do something like this as well. Throw new arithmetic exception. So what in your code, basically if you want to throw your exception explicitly, you want to throw the exception explicitly, so you can use this keyword throw new arithmetic exception. So basically you are creating an object of the exception that you want to throw new arithmetic exception. This syntax you already know, right? This is for creating the object of the class, and you are basically creating an object of the arithmetic exception here. And when you do throw, basically you as the user are explicitly trying to throw that arithmetic exception. And see, if j's value is not equal to 0, then we'll print out some value, and then we are returning I by j. And then we have some kind of like finally block where we are printing out some statement like this will be executed. So this is one example where the throws demo is being shown. See, throws is being declared at the throws is being like defined at the method level itself. Like this method wants to throw some kind of exception, and that is basically an arithmetic exception. So see, whichever method will be calling this dividing numbers method will have to basically handle that exception. So this is an example of error propagation. So we have now this custom exceptions. Okay, is it like getting too late for you, or if I take like 10-15 minutes? Hello.
I think can we continue tomorrow? Or?
Okay, I'll take this examples tomorrow, then I'll show you this throws throw and also this custom exceptions tomorrow. Okay, no problem. So in this class, I'll again take the demo of this throw and custom exception tomorrow. So until now, while using this try, catch, and finally, and also why we basically use finally, why we basically use try, why we basically use catch. So try is basically used for throwing an error. So whenever you feel that your code might throw an error, try to wrap those piece of code in your try block, and the catch block is basically used for handling the exception. And the catch block, whatever exception you are expecting, try to put the specific exception types in that particular catch block. If not, then the parent exception class will handle that particular exception. And also remember one thing, that the parent class exception must be placed at last. Means first the child class exception, that is like more specific, should be kept, then followed by the parent class exception. And why we basically use finally, is generally used for releasing the resources from your uh, Java application. And finally is executed irrespective of whether your catch block was executed or whether the try block threw some error or not. Your finally block still gets executed. And we have seen that example of system.exit and return statements as well, right? So go through these contents today. I will send out this demo exercise, and also the video will be available by the end of the day, so you can go through that. If you still have any questions, you can ask me tomorrow. So we'll wrap up the class here itself.
Recording stopped.